Hello and welcome to another one of D's ADD videos. Today we're going to look at some basic examples of limits. Alright, let's get started. As you know, the first step to any limit is just to plug in. If you get an answer, like on this problem, when I plug in a 1 everywhere I see an x, I get 3. I'm done. I move on to the next problem. Okay? They're not going to all be that easy. For this one here, we have 2, we plug in, we get 2 plus 1 over 2 minus 2. And already you should see a problem because we get over 0. Right, infinity, or it does not exist. Okay. In limit land, we say it does not exist. If it was just functions, we'd say undefined. But since we're talking about limits, it does not exist. Remember, there's number over 0, like we just exhibited, was infinity, and if it's number over infinity, it's 0. Keep that in mind. Okay. Oops, sorry about that. And then if it's 0 over 0, like this one here is about to be, or infinity over infinity, then you write down I and D for indeterminate, and you do some sort of algebra. So in this case, if I plug in, I get 0 over 0, 9 minus 9, over 3 minus 3. And then I do the algebra. So when I rewrite the problem, I have to rewrite the limit. And when you factor the numerator, the only thing you can do with that polynomial is factor it. You should notice that one of the factors is what you have in the denominator. I keep hitting the button. Then at that point, we have x minus 3's that cancel. You then have rewritten the problem, so you have to reevaluate it. Anytime you give a limit a new appearance, you have to plug in. So that gives you 6, and then you're done. All right, let's see. For these last two, same concept. So when I plug in my 4, I get 2 minus 2, which is 0 over 0. And I forgot to write down I and D on the last problem. I apologize. It stands for indeterminate. It means you can't figure it out the way it sits. Yes, they both go to 0, but at different rates, so you can't cancel them out. So what we do with square roots that are not going all the way across is you want to get from this to a squared minus b squared. So let's go back and think. What would I take? I have a minus b. There's my a, there's my b. And I want to multiply it by something to give me a squared minus b squared. What is that something? Well, if you guys remember your factoring, you should know that that something is a plus b. So that's called the conjugate, and if you multiply it times the top and the bottom, and what I recommend, oops, that's supposed to be an x there, sorry. What I recommend is that you don't distribute this denominator, don't FOIL it out, because 9 times out of 10 what happens is this will cancel with what you get when you simplify the numerator. Right, something has to cancel, otherwise this algebra was for no reason. So here, we don't have to FOIL it out. We know that it's a minus b times a plus b, which is a difference of 2 squares, which means you're going to have the square root of x squared minus 2 squared. And then x minus 4, still there, and I'm not going to multiply it with this. So when I square something square rooted, they cancel. If you want to think about it, it's 1/2 raised to the 2 power. So when you multiply 2 times 1/2, you get 1. So it'll be x to the 1 minus 2 squared, which is 4. And looky there, just like I said, you will have that cancel. And remember, if you rewrite a limit, what do? You have to re-evaluate it. So let's re-evaluate this final answer. Last step. So 1 is left when we cancel it out. We are left with root x plus 2. and that's going to give us 1 over root 4 plus 2, which is 1 over 2 plus 2, which equals 1/4. Okay? Last one of these is going to be with a fraction. What I tend to do with this, again, first you would plug in, you would see that you get 1/3 minus 1/3 over 1 minus 1, which is 0, 0 for n indeterminate. And what I do is I find the common denominator of the top, 3 times 2x plus 1, and then this is understood to be over a 1, so the common denominator of actually each of them individually are understood to be over 1. So the common denominator here is a 1, and the common denominator between the top and the bottom is that top, so we would have 3 times 2x plus 1, and if I do this times top and bottom, it simplifies everything pretty quickly. Watch what happens. This times the first expression, the 2x plus 1's cancel, I'm left with 1 times 3 on the top. Okay, what happened there was I had 1 over 2x plus 1 times 3 2x plus 1, and that's over 1. So you can see that's canceling, leaving you 3 times 1. I'm just doing the steps out for you now so that you can see it. And then this one would be the same thing times the 1/3. So it would be 1/3 times 3 times 2x plus 1. Can I squeeze it in? I sure can. The 3's cancel, I'm left with 2x plus 1. Now this is a common mistake that a lot of people do. They'll just leave it like that, but it's 3 minus all of that. So make sure you put that in parentheses. And then here we have 3 times x minus 1 times 2x plus 1. Now just a little cleanup we got to do here, a little algebra. So 3, and then you distribute the 1. So here we're going to get 3 minus 2x minus 1. It's all over the 3 times x minus 1. And since I haven't canceled anything yet, don't FOIL stuff out. You're just going to need to refactor it later. So 3, actually I need to go ahead and combine my like terms. Negative 2x plus 2. At first glance, it might not seem like I have anything that can cancel, but when you plug in your 1, you should still see that you get 0 over 0. And then you notice, wait, there's a negative 2 common to this. Let me pull out a negative 2. So if you pull out a negative 2, again, you should be writing the limit statement all the way down. Negative 2, and then you get x minus 1, and lo and behold, you have an x minus 1 on the bottom. And they cancel. So now that you finally canceled it and given your limit a new appearance, you rewrite your limit. You should have been doing this every step. I apologize that I did not on that last problem. And then when you plug in a 1 there, you get 2 plus 1 is 3 times 3 is 9, negative 2/9. All right? So I hope I've cleared up any confusion that you might have. You need to practice, practice, practice. That is the key to all of this, making it all easier, getting rid of all of your anxiety is by practicing. If you know every type of problem they're going to give you, you're not going to worry. You're going to sleep soundly the night before your test or your quiz. But if you just started studying the night before your quiz, then good luck. All right. Thank you and have a nice day.